Hey guys, welcome to Aloha Finances. I started this website to pursue greater knowledge in the areas of quantitative finance and data science. So most of what I'm going to teach is going to focus on microeconomic and financial theory with a small amount of mathematics needed for our programming we're going to be doing. And all tutorials are going to focus on modern portfolio theory for now with computation done in Python and R. And then supplemental mathematical and statistical programming notes will likely be added to the end of these videos. I hope you enjoy. Our first video is going to focus on importing, manipulating, and summarizing industry return data in Python. Successive videos will then start to focus on the meat of the website, which revolves around portfolio optimization. We'll continue to dive deeper into these topics and eventually touch on active investing from a quant's perspective. Let's get started. The first thing we need to do is make sure you have the Anaconda Navigator downloaded. And if you haven't done so already, I would just Google it quickly. This is going to allow us to launch the Jupyter Notebook. And then once you've launched the Jupyter Notebook, we're going to want to create a Python script that's saved to a specific folder. And what folder you choose isn't as important as remembering where you saved it, because the data we download is going to be needed to be saved in the same directory. So next we want to go to my website at Aloha Finances. My website at alohafinances.com and need to go to the download section so we can download our spreadsheet data and import it into Python. So download the 47 industry days data, and we want to save it into the same working directory as our Python script. And just beware it's in a zipped folder, so you may need to take it out before you import it into Python. We're ready to get started in Python, and the first thing we need to do is download the numpy and pandas library, because it's going to allow us to more easily manipulate and analyze large data sets. We're going to denote them as NP and PD, so when you call them up, you're not writing out the library name every time. Let's import some data. Let's assign the variable data and then recall the PD library using the read_CSV function. And then in single quotations, put the file name where we saved the data down and then .csv because it's a CSV file. Now let's make sure we imported this correctly. Let's use the data.head function and let's execute that line of code. And you can see the 47 industry returns as well as the excess return on the market and the risk-free rate has been uploaded. Next, we're going to rename the first column to year to make subsetting easier later. So we're going to set the variable data equal to data.rename and then the columns, which is equal to a curly bracket, what the column was currently named, which is unnamed, semicolon or colon 0. And then we're going to set that equal to another colon, single quotations, year. And then using the data.head function again, you should be able to see that the first column has been renamed as year. And you can see it there. Next, we need to concatenate the columns of the dates, excess industry returns, and excess market returns into one matrix. We'll start by assigning the variable dates equal to data.iloc, which is just an integer location-based indexer function. And for the excess return on the markets, we're again going to use the data.iloc function, and we're going to subset all rows denoted by the colon, and then use the column or use the comma to get to the columns and subset it to the 48th column of our data set. The excess industry returns is going to be a bit trickier. We're going to need to implement a process called broadcasting. So first we're going to assign the variable rf equal to a numpy array. And then the first argument is going to be our object, which is data.iloc. And again, we're subsetting all rows. And then we're going to do it to the 49th column, which is the risk-free rate in our data set. And then for return on the industry, we're just going to use the data.iloc function again, subsetting from the first column to the 48th column. And that should include all of our gross industry returns. Next, we need to calculate the excess industry returns by subtracting the risk-free rate from the daily returns. But these are arrays with different dimensions, so without getting too technical, we need to implement a process called broadcasting. This is done by reshaping the risk-free matrix to an m/1 matrix so that that vector can be applied across all of the industry returns. And then finally, we need to concatenate the three arrays that we made. So we need the dates column, we need our excess return of the industries, and the excess return on the market. And then we'll set the axis equal to 1, meaning we're linking via columns. And if we look at the returns, we can see we have our years, we have our 47 industries, as well as the excess return on the market. Now to define our sample period beginning in 2009, spanning through 2013. So first we're going to assign the variables y beginning and y end, denoting it as our sample periods between 2009 and 2013. We'll then set the variable returns equal to our returns variable, and then we're going to be subsetting here. So the returns variable subsetting single quotations our year column. Now we want that to be greater than our sample period, which is 2009 times 10,000. If you look at the actual data within the year column, you see that the dates are multiples of 10,000. So we'll then utilize the AND function and again say the return subsetting the year column, and that's going to be less than our ending sample period plus 1 to include 2013 and multiply times 10,000. Now, if we populate this code and execute it, we can see that now our sample data is defined between 2009 and 2013. The final step in this video is to calculate sample portfolio statistics for unoptimized portfolios. So we're going to start by assigning the variable DPY equal to 252, or the number of trading days per year. And then we'll set our mu vector equal to our returns using the iloc function, again, subsetting from the first column to the 48th. And then we're going to take the mean, and then we're going to take the column-wise mean. So we'll set the axis equal to 0, and then we'll multiply it by the number of trading days per year to annualize it. And you can see that we populated the mean for each of our 47 industries. Now we can do the same thing with our standard deviation of the 47 industries. We can go ahead and copy this down. And we only need to make 2 small changes. So instead of the mean, we're obviously taking the standard deviation. And then instead of multiplying it by n, we need to now multiply it by the square root of n. And that's denoted by the POW function, or power. And you can see that those standard deviations there. We can now easily calculate the mean and the standard deviation of the total market just by setting the variable mu_m equal to our previous mean calculation, but instead of subsetting from the first to the 48th column, we're only subsetting the 48th column. And we can populate that and see the annual return on the market from 2009 to 2013 was 19.27%. Same process goes with the standard deviation. We can just copy that code down, remove the subsetting from the columns, and we can see that the standard deviation of the market for our sample period was 19% roughly. To get the average return on an equally weighted portfolio, all we need to do is assign the variable mu_e for equally weighted is equal to our mu vector, or our 47 industry returns. And we're going to take the average of all those, summing column-wise, and we can see that the equally weighted portfolio returned 22.3% over that. Calculation for the standard deviation of the equally weighted portfolio is provided below. Just be careful when you're summing column-wise or row-wise, because this calculation is a bit different than the other ones. This is the end of this video, but in the next one, we'll look to optimize some portfolios and compare them to the portfolios we constructed today.